HCF, or halax fluorinated ethylene propylene cable, is unsuitable for use in emergency power circuits. The primary reason for this restriction is the emission of toxic fumes when the cable is subjected to fire or extreme heat. During an emergency situation such as a fire, the integrity of electrical systems becomes paramount. Emergency power systems are designed to provide essential services like lighting, fire pumps, and communication systems, ensuring the safe evacuation and operation of critical equipment. The selection of appropriate wiring methods for these systems is crucial to maintaining their reliability and minimizing potential hazards. HCF cable, while offering certain advantages in terms of flexibility and ease of installation, poses a significant risk due to its combustion byproducts. When HCF cable burns, it releases highly toxic fumes, including hydrogen fluoride. These fumes can quickly incapacitate individuals, hindering their ability to evacuate the building or operate emergency equipment. The presence of toxic fumes in a fire situation can severely compromise the effectiveness of emergency response efforts and increase the risk of fatalities. Building codes and electrical standards, such as the National Electrical Code, prioritize the safety of occupants and emergency responders. These codes specify the types of wiring methods that are permitted for use in emergency systems, taking into account their fire resistance, smoke generation, and toxicity characteristics. HCF cable typically does not meet the stringent requirements for emergency circuits due to its toxic fume emission. Alternative wiring methods that are commonly used in emergency power systems include mineral insulated cable, also known as MI cable, and fire-rated cable with low smoke and halogen content. MI cable is a robust wiring system that consists of copper conductors insulated with magnesium oxide and enclosed in a seamless copper sheath. It is highly resistant to fire and physical damage, making it an excellent choice for critical circuits. Fire-rated cables with low smoke and halogen content are designed to minimize the release of smoke and toxic fumes during a fire. These cables are typically constructed with specially formulated insulation and jacketing materials that are resistant to combustion and do not produce harmful byproducts. The selection of appropriate wiring methods for emergency power systems should be based on a thorough evaluation of the building's occupancy, fire protection measures, and the specific requirements of the emergency system. It is essential to consult with qualified electrical engineers and code officials to ensure that the wiring methods meet all applicable safety standards. In addition to the selection of appropriate wiring methods, proper installation practices are also critical to ensuring the reliability and safety of emergency power systems. Wiring should be installed in accordance with the manufacturer's instructions and applicable codes and standards. Connections should be made using approved connectors and terminals, and wiring should be protected from physical damage. Regular inspection and testing of emergency power systems are also essential to verify their proper operation and identify any potential problems. Inspections should include a visual examination of the wiring, connections, and equipment, as well as functional testing of the emergency power source and transfer switches. Any deficiencies that are identified during inspection should be promptly corrected to ensure that the emergency power system is ready to perform its intended function when needed. In summary, HCF cable is not suitable for use in emergency power circuits due to the emission of toxic fumes when burned. Alternative wiring methods such as MI cable and fire-rated cable with low smoke and halogen content should be used instead. Proper installation practices and regular inspection and testing are also essential to ensuring the reliability and safety of emergency power systems. The selection of appropriate wiring methods for emergency power systems is a critical aspect of building safety. By understanding the risks associated with different types of wiring and adhering to applicable codes and standards, it is possible to minimize the potential for fire-related hazards and ensure the safety of occupants and emergency responders. Consideration must be given to the specific application of the emergency power system. For instance, a hospital may have different requirements than a commercial office building. Hospitals often require a higher level of reliability and redundancy in their emergency power systems due to the critical nature of their operations. In such cases, the use of cable may be preferred over other wiring methods. Commercial office buildings may have less stringent requirements for emergency power systems, but the selection of appropriate wiring methods is still important to ensure the safety of occupants. Fire-rated cables with low smoke and halogen content may be a suitable option for these applications. The National Electrical Code, or NEC, provides detailed requirements for the installation of emergency power systems. Article 700 of the NEC covers emergency systems, and Article 701 covers legally required standby systems. These articles specify the types of wiring methods that are permitted for use in these systems, as well as other requirements for their installation and operation. The NEC also includes requirements for the fire resistance of wiring methods. Section 300.21 of the NEC requires that wiring methods be installed in a manner that does not spread fire or contribute to the spread of fire. This requirement is particularly important for emergency power systems, as these systems are intended to operate during a fire. When selecting wiring methods for emergency power systems, it is important to consider the environmental conditions in which the wiring will be installed. For example, if the wiring will be exposed to moisture or corrosive substances, it is important to select a wiring method that is resistant to these conditions. An cable is a good choice for wet or corrosive environments, as it is completely sealed against moisture and other contaminants. Fire-rated cables with low smoke and halogen content are also available with special coatings or jacketing materials that provide additional protection against environmental factors. The cost of different wiring methods is also a factor to consider when selecting wiring for emergency power systems. Cable is typically more expensive than other wiring methods, but it offers superior performance and reliability. Fire-rated cables with low smoke and halogen content are generally less expensive than cable, but they may not offer the same level of fire resistance. The decision of the best wiring method will ultimately depend on a variety of factors, including the specific requirements of the emergency power system, the environmental conditions in which the wiring will be installed, and the budget for the project. Consulting with qualified electrical engineers and code officials is essential to ensure that the selected wiring methods meet all applicable safety standards and provide the necessary level of performance and reliability. Continuing education is also important for electrical professionals who work with emergency power systems. The NEC is updated every 3 years, and it is important to stay current with the latest changes to the code. There are many resources available for continuing education in electrical safety, including courses, seminars, and online training programs. Emergency power systems play a vital role in protecting life and property during emergencies. By carefully selecting and installing appropriate wiring methods, it is possible to ensure that these systems will operate reliably when they are needed most. Understanding the limitations of certain wiring types, such as HCF cable, is crucial for maintaining a safe and effective electrical system. Always prioritize safety and consult with qualified professionals to ensure compliance with all applicable codes and standards. When considering the overall design of an emergency power system, the location of the emergency generator is also a critical factor. The generator should be located in a well-ventilated area and protected from the elements. It should also be located in a secure area to prevent unauthorized access. The generator should be sized appropriately to meet the demands of the emergency loads. It is important to consider the starting current of motors and other equipment when sizing the generator. The transfer switch is another important component of an emergency power system. The transfer switch automatically switches the load from the normal power source to the emergency power source when a power outage occurs. The transfer switch should be reliable and should be able to switch the load quickly. The emergency power system should be tested regularly to ensure that it is operating properly. The testing should include a functional test of the generator and the transfer switch. The results of the testing should be documented and kept on file. Proper maintenance of the emergency power system is also essential to ensure its reliability. The generator should be serviced regularly according to the manufacturer's recommendations. The batteries should be checked regularly and replaced as needed. The wiring and connections should be inspected regularly for signs of damage or corrosion. The emergency power system should be designed and installed in accordance with all applicable codes and standards. The NEC provides detailed requirements for the installation of emergency power systems. It is important to consult with qualified electrical engineers and code officials to ensure that the system meets all applicable requirements. Emergency power systems are complex and require careful planning and execution. By following these guidelines, it is possible to ensure that the emergency power system will operate reliably when it is needed most. It's also good to ensure that all emergency lighting is functioning correctly. This includes exit signs and pathway illumination. Regular inspections of emergency lighting are necessary to ensure that batteries are charged and bulbs are working. Backup power for fire alarm systems is also critical. Fire alarm systems must have a reliable backup power source to operate during a power outage. This power source is typically a battery backup system. It's also important to verify that all emergency communication systems are functioning correctly. This includes two-way radios and public address systems. These systems are used to communicate important information to building occupants during an emergency. The building's emergency plan should be reviewed and updated regularly. This plan should outline the procedures for responding to different types of emergencies. Building occupants should be trained on the emergency plan. They should know what to do in the event of a fire, power outage, or other emergency. Emergency drills should be conducted regularly to test the emergency plan. These drills help to identify any weaknesses in the plan and to ensure that building occupants are prepared to respond to an emergency. Proper signage is essential for guiding building occupants during an emergency. Exit signs should be clearly visible and well lit. Emergency exit routes should be clearly marked. Fire extinguishers should be readily accessible and properly maintained. Building occupants should be trained on how to use fire extinguishers. Automatic sprinkler systems are an important part of a building's fire protection system. These systems automatically release water to suppress a fire. Sprinkler systems should be inspected and maintained regularly. Fire dampers are used to prevent the spread of fire through ductwork. These dampers automatically close when a fire is detected. Fire dampers should be inspected and maintained regularly. Smoke detectors are used to detect smoke and alert building occupants to a fire. Smoke detectors should be installed in all sleeping areas and on every level of the building. Smoke detectors should be tested monthly and batteries should be replaced at least once a year. Carbon monoxide detectors are used to detect carbon monoxide, a deadly, odorless gas. Carbon monoxide detectors should be installed near sleeping areas and in areas where fuel-burning appliances are used. Carbon monoxide detectors should be tested monthly and batteries should be replaced at least once a year. Regular maintenance of all safety systems is essential to ensure that they will operate properly during an emergency. This maintenance should include regular inspections, testing, and repairs. A qualified contractor should be hired to perform the maintenance. A record of all maintenance should be kept on file.